The last video shows how we can develop a game called NIM. There seems to be many components or modules in the game and can be difficult to have a good overall view. So, how should one manage such a seemingly complex task of development at our current level? I take this opportunity here to present the different viewpoints on seeing the whole development from the functional abstraction and the data abstraction viewpoints. That is, no matter how big a system such as a game, it is no more than two aspects here: the kind of data that we have to deal with and the various processes that we need to have to work on the data. From the functional point of view, we need a game loop in the whole process till the game is over. From the data abstraction point of view, we need to have data to keep track of the game states and to keep track of the history. Within each game loop, we have human and a computer to take turn to play. To keep track of the game states is to keep record of each pile and its number of coins. To keep track of the history is to keep record of the game states over time. With this understanding, we can go down to address each of them to complete the development. Usually we start with the data before the process. We mentioned this in some earlier video. The choice of data structure can affect greatly the complexity of the processing. So this is also why we usually start with data. In the event that we later on found that we don't have enough data representations of the processing, which usually should not be the case if you have put in enough thought on the objective of the systems, we need to go back to decide on the data before continuing with developing the process. This can be very costly in the whole development. So the intention is to pick the right way to store our information. For us here, we use a tuple to keep track of number of coins in each pile, one number per pile. So tuple is demonstrated here, though you will know later on that there is better alternative to tuple since tuple is immutable. What about the history? Because it needs to be last in first out, the stack is the natural choice here, as you will learn in computer science in general. With the data decided, we need to create the data and to maintain the data. Here are the codes. Define make game state with input n and m is to return a tuple n, m to keep track of the number of coins in pile 1 and the number of coins in pile 2. So the game state is make game states. So there are 5 coins in the first pile and 5 coins in the second pile. We also need to keep the history, so we have game stack equal to make stack, which is a system function. So this is to create the tuple, this is to create the stack. So we next need to maintain it. To maintain it, we remove coins from pile. So we have this routine, define remove coins from pile. Given the game state, the number of coins to remove from which pile. And we also have size of pile to query. Given the game state on which pile, we return the number of coins in that pile. So these are the 3 functions that we have to do to create, maintain, and to query the data that we have for the applications. In general, you have to create, maintain, and query data in any other systems too. With the necessary data in place, we next need to process them. The processing, as we said, it's a main loop, which is the game loop, and the computer and the human take turns to make a move. So within each game loop, we have the play, and you display the game states. If the game is over, you announce the winner. And then if it is not over, the player is a human, the human will make a move and reset the player to be the computer next. And if the player is the computer make a move and set the human to be the next player. In the iterative versions, we see the following. The game stack is equal to make stack, define start, it's the starting of the game, and you have game state to create the state of the game, to create a stack to keep the history of the game, and you start playing the game. And define the play game, which is to show the states, set the current player to be computer so that the human is going to make the first move. While true, so this is the main game loop. If the current player is a computer, so the player will have to be the human now, and the human make a move. Otherwise, the player is going to be the computer and computer make a move. After the move, you check is the game over. If it is, announce and break out from the while loop. Otherwise, you display the game states and repeat the loop, and so on. So this is the iterative versions, just simply unfolding the recursion into more explicit statements here. So all in all, what you saw are that the development is such that you choose the correct data structure, and the data structures are to be worked on by the algorithm or the process. And this is all we study also. As we saw, computer science, it's actually algorithm plus data structure. Should you encounter other developments, you can also use this method to think about them and to come up with the data structure first, and then come up with the algorithm to work on the data structure to complete the whole development.